Okay, continuing where we left off, this is still section 10.2. So now that we are very comfortable with the sums and we get those out of the way, we know if we are ever asked to find a sum, then the series, either we're going to use this telescoping idea, the S sub n part, or if it's geometric, then that's simple. Now we have a theorem. This theorem says if a series converge, then automatically the limit as n approaches infinity. Remember we said they write limits sometimes like that. This is saying the limit as n approaches infinity of a sub n equals 0. Which means if a series converge, the limit of the sequence equals 0. I could use analogy in section 10.1 for any series, for any sequence that they ask if it converge or diverge. If I could show the series converge, then automatically the limit equals 0, and if the limit exists for a sequence, then that sequence converge. Now, out of this comes really this, which is the reverse. What's the reverse? A implies B. The one conclusion you can get out of that, not B, will implies not A. So, if it rains, there must be clouds. If it doesn't rain, that doesn't mean there are no clouds. There could be clouds. Right? So if it rains, there must be clouds. And if there are clouds, that doesn't mean it's going to rain. But if there are no clouds, there's no way it could rain. So the statement is, if it rains, then there must be clouds. That's an if-then statement. No clouds will indicate no rain. That's always true in math, the if-then statement. So I'm going to use this in reverse. That is, if I take the limit as n approaches infinity and I don't get it to be exactly 0, then this series does not converge, and this is called test for divergence. We have 10 different tests altogether, so you're going to start quoting those. This converged by what, this diverged by what, and you have to quote them. The 3 letters will do. So this says this series diverge if the limit failed to exist or is different from 0. Well, different from 0. If it doesn't exist, that means it's not 0. So very simple. I'm given a series. I take the limit as n approaches infinity. If that doesn't equal 0, then this series diverge. End of discussion. So now we have a couple of tools, and let's start playing with those. On your test, I never specify what to use. I give you a bunch of those, and I say, does the series converge or diverge? So use the nth term. I will never say use the nth term, or the test for divergence. I'll say, does this series converge or diverge? Test for divergence works if this limit doesn't equal. If it equals 0, you're out of luck. So meaning, if there are clouds, that doesn't mean anything. It could rain or it could not rain. So be careful with that. That's the purpose of this exercise. Or show this diverge, or the test is inconclusive. Students fall into the idea of if the limit equals 0, that converge. For a sequence, that's true, not for a series. And if I'm taking the limit as n approaches infinity, I could use L'Hopital twice, or I could divide by the highest power term of the denominator. If I divided this by n and this by n, doesn't that mean I'm dividing by n squared? That'll be a 1 because that's over n, and that'll be 1 plus 1 over n. This is a lot more efficient than L'Hopital if you're dealing with rationals, and you're left with 1 over 1 times 1, which is 1, doesn't equal to 0. So the limit of the sequence doesn't equal to 0. Therefore, the series diverge by test for divergence. So how good are you with those limits? How well do you remember section 4.5? Oh wait, you don't have to remember it. We covered it. How about this problem? I'm going to divide by the highest power term of the denominator. You could use L'Hopital, but this is faster. This is if I take the limit as n approaches infinity of 1 plus 3 over n squared and 1 over n. That's a 0, that's a 0. That's 0 over 1, which is 0. What does that mean? Therefore, the series, therefore, it's inconclusive. You can't figure out anything out of it. So, if it rains, there must be clouds. If there are no clouds, that's this part. If there are no clouds, it can't rain. But if there are clouds, that means you're out of luck. Right? If you keep up with the homework and ask the questions, then you should pass the class. If you don't pass the class, that means you did not keep up with the homework and you did not ask questions. Right? But if you passed, it could be that you did the homework or you didn't do the homework. If I take the limit as n approaches infinity, and if I divide by the highest power term of the denominator, actually here, probably I'm better off using L'Hopital. Limit as n approaches infinity of e to the n over e to the n plus n, that's infinity over infinity. Because if I divide over e to the n, I have to show that that's 0. That's work. It's easier just as is. Limit as n approaches infinity, e to the n over e to the n plus 1. That's still infinity over infinity. I'll hit L'Hopital again. Those cancel out. I'm left with 1, which doesn't equal 0. What does that mean? That means this series diverge. That indicates that, therefore, diverge by test for divergence. You have to always state diverge by what, converge by what. And how about this problem? Well, this problem is really a bit trickier than it looks, only until you see it once. And once you see it once or twice, you already saw it once. You know if you let n equal 0, this is 1. N equal 2, this is n equal 1, this is negative 1. Cosine of 2 pi, cosine of 3 pi. You know this is the series n equals 0 to infinity of negative 1 to the n. If I take the limit as n approaches infinity of negative 1 to the n, isn't that always a plus 1 or a minus 1? Which means it does not exist. Doesn't that automatically mean it's not 0? Therefore, what diverge? The series diverge. Diverge by test for divergence. Up there they said use the n test. Now they're not specifying. Use whatever you like. Well, we don't know that many tests. We know few tests. We know how to take a limit because we reviewed L'Hopital. So, if I take the limit as n approaches infinity of, isn't that really 2 to the 1/2 raised to the n? Isn't that 2 to the n over 2? That's one way of looking at it. Another way of looking at it is, so you could say that's infinity. Or you could say the limit as n approaches infinity of square root of 2 to the n equal infinity, not equal to 0. Therefore, this diverge by test for divergence. How do I know that? The base is bigger than 1. If the base is bigger than 1, this is exponential growth. Another way of looking at this, you could say this is geometric if you like. You could say this is geometric, r equal radical 2, which is bigger than 1, therefore diverge. If you use the letter G and R, I know you mean geometric series. You don't have to say but geometric test. Otherwise you have to state that. This, wouldn't you say this is negative 1 to the n over 5 to the n? If I take the limit, as n approaches infinity, that will be 0. That's useless. Well, wouldn't you say this is the series n equals 0 to infinity? Can't I say that's negative 1 over 5 to the n? If I use the letter G, you're saying this is geometric. R is negative 1/5. In absolute value, that's less than 1. Therefore, the series converge. The reason you don't have to say by what, you did show me it's geometric. If you use the letter R and the letter G, you better be talking about geometric. This came up. I could use L'Hopital. You're allowed to say the limit as n approaches infinity of 1 minus 1 over n to the n is e to the negative 1, which is 1 over e. It doesn't equal 0. Therefore, diverge by test for divergence. Test for divergence we try in every single problem. Every problem. You could do this in your head, really. And if you do enough of those, unlucky for you, I'm going to give you enough of them in the homework so you get to do them. You'll be able to figure that out just by looking at it. If I'm dealing with this, L'Hopital is not the way to go. Reason for that, you pick up those again. Instead, if you divide by the highest power term of the denominator. So 3 to the n over 4 to the n. That's a 1. That's a 1. That's 2 to the n over 4 to the n. That is the limit as n approaches infinity. That is 2 over 4 to the n plus 1, and that is 3 over 4 to the n plus 1. Doesn't this approach 0 and this 0 because those are exponential decay? So you're left with 1 over 1, which is 1. That limit doesn't equal 0. Therefore, diverge by test for divergence. If you say diverge, you have to say by what? If you say converge, you have to say by what? The only reason I didn't say here by geometric series, I used the letter G right there. And you have to do the same. Let's look at these problems. It says, find the value of x for which the geometric series converge. And find the sum. By saying find the sum, it's either geometric or I'm going to have to use telescoping. This doesn't look like telescoping. So if this is geometric, I need to get R because geometric depends on R. This is the series n equals 0 to infinity. And wouldn't you say this is negative 1 to the n over x to the 2n? And if I push it even further, wouldn't you say that's negative 1 over x squared to the n? Because geometric series, if you recall, the general term is a sub 1 times r raised to the n minus. So you're trying to get an r in there. And there it is. We know that this is geometric. They told us to begin with. R is negative 1 over x squared in absolute value. I need that to be less than 1. For what values of x? No. Find the values of x for which the geometric series converge. It'll converge as long as negative 1 over x squared is less than 1, or simply 1 over x squared in absolute value. That's always positive, isn't it? Less than 1. So that will converge. This will be less than 1 as long as that's bigger than 1. So as long as x is between negative infinity and negative 1, not included, or x is between 1 and infinity, this will converge. And what does the sum equal? The sum, this infinite sum, will equal the very first term. Throw n equals 0, you get a 1 over 1 minus r. What's r? Negative 1 over x squared. Okay, that doesn't look like it. The very first term divided by 1 minus r. That's a plus, and if you clear the fractions, that's x squared over x squared plus 1. There it is. Found the sum as well. Alright. And one more. Again, they told me this geometric. If not, I need to figure that out. Well, everything in geometric series depends on r. Wouldn't you say in this case r is natural log of x in absolute value? I need that to be less than 1. which means I need natural log of x to be between 1 and negative 1. And that means x is between e to the 1 and e to the negative 1. As long as x is between those two values, I'm guaranteed that this is true. And this infinite sum will equal the very first term. What would be the first term? Oops, wrong color. What would be that first term? Let n equal 0. That is 1 over 1 minus r. There it is. And the rest of the homework is right there. I need you to do number 31 through 35 odd, and 53 to 71 every other odd, and 81 to 85